Okay, guys, so this will be our outline for the quiz in series and sequence, the test. You might still be working on your hand in, that's fine. Okay, so taking a look here at what I have on screen, this is our formula sheet. Okay, so the first one here is the equation for general term for an arithmetic sequence. And yes, I will have the typing beside each equation. I will not tell you what everything is, but I will tell you what the equation's for. Okay, here's the sum of a series that's arithmetic when you have no given n. Oops, I guess there is a given n there. That's an error. Let me erase that part. There we go. Okay, and then we have sum of a series for an arithmetic series. N and D are present. T1 as well, probably. Here we have the general formula for geometric sequence. Here's the sum of a geometric series when you have an n value, and here's one when you don't have the n value. Okay, and the last one here is the infinite geometric series, and you can see the first question there. Whoops, but that's okay. And this is what I'll send out as when your exam gets sent out. You'll have this as a formula sheet. So let's just hit enter. There we go. Yeah, that's the way we want it. So that's the sheet that you get for a formula sheet. Okay, and that is the first page of our test, actually. Okay, so let's move that out of our way. And what I want to do is I want to outline some more tests in there. What I want to do is I want to outline each question that's on the quiz. Okay, there's going to be a few different kinds of questions on the quiz. And then we'll do some examples or something similar to that. So question number one is a definitions type question. Okay, so it's worth, let me see here, what is it worth? Let me just shrink this down. There we go. And get the title up here so we know what we're doing here. Okay, so this is the outline for the series and sequence quiz. Okay, so the first question, and let me get my other outlines here, my outline notes up. Where are they? Right there. All right, so series and sequence, it's a define type question. So question one, okay, it's a define, explain type question. It's 3 points and there's 3 parts to it. What are you going to need to know? You're going to need to know 3 of the following. Okay, and it depends on the year which 3 I choose. You probably saw that there on that original one, but that might be different because, depending on the year, I change it up. Okay, so the first thing is the difference between a series and a sequence. Okay, so if you don't know what that is, a sequence is depending if it's arithmetic or geometric, it's a series of numbers with commas in between that has a common difference if it's arithmetic or a common ratio if it's geometric. A series is the same thing except you add each of the terms together as you go. So they're being added. So the difference is one is added and the other is not. Okay, the difference between geometric and arithmetic series or sequences. Okay, so in one, the arithmetic, you are having a common difference, and in the other, the geometric, you're having a common ratio. Okay, knowing what an infinite series is. Okay, and knowing what divergent, I guess we'll put that in the second part here. Knowing the difference between divergent and congruent. And congruent series. Okay, I'm just going to pause here for a sec and make sure I have everything, plus check, as you probably heard my phone go there. I'll just pause for a quick. No biggie. Okay, so we also might have the conditions for an infinite geometric series. I don't know if I'm going to put that one on there because I don't think we covered that one. Actually, we did. That's right. That's where the R has to be between 1 and -1, right? Okay. What does general term mean? And what I mean by that is the general term is like the Tn value. Okay, depending on what the n value is, Tn value. When you want to find the general term, you leave the n blank, and you leave the Tn blank. All right, so that's the first question. We're going to pick 3 of those 6. Okay, and 1 mark each. Question number 2. Okay, question number 2 is a series and sequence are shown. So there'll be a list of some series and sequences. And you have to classify them as neither, or sorry, gotta spell that right. Okay, they could be a neither, they could be an arithmetic series or sequence, and or you could have geometric. Series or sequence. There's actually 5 choices. Okay, so for example, and that's worth 5 points. Okay, let's do a quick example here. So example, let's say if I had 3, 5, 7, 9, dot, 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 oop, not dot, dots. These dots here. Okay, this would be, okay, we are adding, so, and it's got no pluses and minuses in between, so this is an arithmetic sequence. Okay, maybe I had something like -1, 3, -5, -7, dot, dot, dot. Okay, well, we're looking for a common difference. We added 4, and then we ended up subtracting 8, and then we subtracted 2. Well, it doesn't multiply out evenly as well. So this one looks like it's just a sequence that is neither arithmetic or geometric. So it's neither. Or not one of those 4. I guess there's infinite geometric series too, right? I didn't put it in here. So there's actually 6 or 4 or 5 of them. So we could also have an infinite geometric. Series. Boy, I almost forgot about that one. So there is actually, you can have a arithmetic series or sequence, that's 2. A geometric series or sequence, that's another 2. And then you can have a infinite geometric series, which is a sub thing of geometric series. Okay, so that's going to be question 2. So you're going to have 5 of these lists, and then you have to tell me what kind they are based on looking at them and figuring out that they have a common multiple ratio or a common difference, and whether it's their sequences or sums or series. Okay, so then let's go on to question number 3. So that's the first 3 and 5 points for 8 points. So question number 3. Okay, question number 3, there's 2 parts to it. Okay, and then we're going to be looking at 1 arithmetic and 1 geometric question where you will need to find, what is it here? Find some terms given some variables. Given a variables. Okay, so first let's do an example here, and that's worth 4 because one will be 2 points each, so 4 points. Okay, so for example, I might say something like this. The first term of a geometric sequence is 2, and the common ratio is 3. Okay. Find the 12th term. Okay, something like that. So that's just using the general form. Oops, question mark, not that symbol there. Oops. Okay, let's just work this one out so that we can do it. So if we were to do this one, okay, so we want to find Tn of a geometric 1, so that's T1 times Rn minus 1. So we want the 12th term, so T12. T1, first term is 2, R is 3. We want the 12th term, 12 minus 1. So this is going to be 2 times 3 to the power 11. So you go 3 to the power 11, and then you multiply by 2, do order operations. Take your calculator out. 3 to the power of 11 times 2 gives us 354,294. Okay, so that would be a two marks. And then I would do a similar one that would be of the arithmetic equation. Okay, so question 4, so there'll be another one, but it'll be arithmetic. So there'll be 2 parts to that one. Okay, let's go on to question number 4. You're like, hey, Mr. E, well, how many are there? I think there's 7 total questions on the quiz, so it's not too long. So this is number 4. And what I'm looking at in number 4 is you're going to be given 2 terms of the sequence, and you're going to have to find T1 and R or T1 and D, depending on if it's an arithmetic or a sequence. So this is the 2 unknowns, 2 equations. So this is the given 2 terms in an arithmetic, or could be geometric too. Sequence. Find the first term and B or R. Depending on if it's geometric or not. So let's say that we had, for our example, let's say we had this one here. I have to do this in marker. So for my example, how much is it, Mystery? How much am I going to put on that one? So that one, number 4, is worth 4 points, it looks like there. Okay, so let's go ahead and do that example. So let's say that T, let's say it's an arithmetic sequence. I'll type it out. What the heck? Make it neater. Okay, so let's say the third term of an arithmetic, we'll go arithmetic in this case, sequence is 16, and the, what do I got here? And the 9th term is 46. Find the first term and common difference. So when you're doing this, this is that simultaneous equation solving type example. Okay, so we have to use the general term formula. So we know that T3, we're only at 19 minutes, so we're still good. We'll be able to get through everything here. T3 equals 16, and T9 equals 46. So we're going to use that Tn equals T1 plus D times n minus 1. Not very neat. Okay. So let's do this. So T3 is 16 equals T1 was, what did I say? The first term is not unknown, right? Plus D, which is unknown, but we're going to have 3 minus 1, which is 2D. Okay, now the next one is going to be the 9th term, which is 46. That's going to equal T1, and 9 minus 1 is 8, so 8D. Okay, so then what we do is we subtract the 2 terms. Okay, and then we've got 30 equals, this cancels out, 6D, D equals 5. Okay, and then we plug it in here, 16 plus T1, or equals, pardon me, not plus, equals T1 plus 2 times 5. So that's 16 equals T1 plus 10, subtract 10, T1 equals 6. So we have our answers of 6 and 5 for that particular case. Okay, it might be a geometric one as well. Okay, so question number 5. Okay, it's a two-parter. It's going to be using the sum of a series formula for arithmetic and one for geometric. So we're using the sum formulas on the next one. So question number 5 is two-parter. Using the sum formulas. Pardon me. Okay, now one is going to will be arithmetic, and one will be geometric. Okay, so what's that going to look like? Well, that'll be 4 points. Well, what's that going to look like for an example here? Well, I've got one here. So let's say find the sum. Let's say this is my series. Okay, I've got 7 plus 16 plus 25 plus dot, 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 all the way up to the 15th term. And it says find the sum. Okay, well, we have to recognize this as an arithmetic series. So D is equal to T2 minus T1, which would be equal to 16 minus 7, which is equal to 9. N is equal to 15. And T1 is equal to 7. So we could plug that into the formula for sums. S15 is going to equal N over 2 times 2 T1s plus D times N minus 1. Okay, so this would be equal to 15 over 2 times 2 times 7 plus D, which is 9, times 15 minus 1, which is 14. So this is 15 over 2, 14 plus, what is that? 9 times 4, 90, and 126. Okay, so if we add that up, 15 over 2 times 140. So 70 times 15. So we take 2 divided into 140. So 70 times 15, 1,050. Okay, so I'm going to do one that's arithmetic. I'll give you one that's arithmetic and give you one that is geometric. Okay, question number 6. Okay, question number 6 is we're going to convert a repeating decimal into a fraction. Let's do that on the next page. Okay, question number 6. a repeating decimal into a fraction using the infinite geometric series method. So, for example, what is okay, and we have to put the repeat sign in there. Okay, we're sitting at around 26 minutes, so we might go into over 30, but I've only got one more example to do. So this would be 0.36 plus 0.0036 plus 0.000036. Okay, so R is equal to, if we divide those two, it's equal to 0.01, and T1 equals 0.36. So S infinity equals T1 divided by 1 minus R. In our case, that's simple. That is just 0.36 over 1 minus 0.01, which equals 0.36 over 0.99. Divide that out and you get 4 over 11. Okay, and then that one would be worth 2 points. I think that's what that one is. Maybe it's 3. Okay, and then a word problem in our last one. Okay. So question number 7, final one, is a word problem. Okay, what kind? It'll be either one of these two. Okay, so you're going to do a geometric growth problem. Okay, so like a population growth. So if I say it's growing by 8%, so you add it to 100, get the R, and then I might want to say, what is the population after so many years? Or it could be an arithmetic sum type problem. Study those two versions. Now, how much is that one worth? I don't know right now. It doesn't say on here. So let me just check real quick with my, where it is. Oops, wrong one. Sorry, guys. Okay, so that one would be worth, let's see where it is here. 5, 6, 7. That one's worth 4. Or no, sorry, 3. I can't see my own writing there. Okay, so that's what will be on the exam. So study the geometric growth problem and study the arithmetic sum type. So this one would be like the population of a city is growing by 8% per year. If the population was 100 in 19 or 2000, what will the population be in 2020? Arithmetic sum one might be something like the one where we did the sit-up question, where you might say, okay, I do 5 jumping jacks in my workout. Every following workout, I add 2 more. How many jumping jacks total would I do in my 15th workout? Something like that. Okay, so you can study those 2 types of problems. Looking at our, I'll have an exam day there. I'll send this out to your supervising teacher. Excuse me for a sec. I'm just closing that down. Okay, so I'll send it out to your supervising teacher. So study that up and pick a day that you're going to do it. Might be right after you get your hand in back or something like that. It's really up to you. I'll send it out to supervising teachers ahead of schedule so they'll have it in their hands. And again, with exams, once you're ready, just email me and say, I'm ready. Send that out to my teacher. I'll be writing it in a couple days or something like that. Okay? So that's been about a 31-minute video. So that's long enough. And we'll start our second unit after you write your